So now let's practice converting things into scientific notation and from scientific notation to standard notation. So starting with the first part, which is converting things to scientific notation. We have to consider, are we greater than 0 or less than 0 in each of these problems? So here we go. I'm going to have to move this decimal point over to the right 1, 2, 3 times before that decimal were to get behind the first non-zero number. So I would write this as 3.95 times 10. Since we went to the right, it's the negative third because we moved it over 3 times. The next number is quite large. So remember, our decimal point is right here. We're going to move that over 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So this becomes 2.36 times 10 to the 9th. The next number is greater than 1 as well, and it's quite large, so we're going to put in a decimal point right here and move it over 1, 2, 3, 4, 5, 6 times. That would mean we've got 4.6 times 10 to the 6th. I bet you're getting the hang of it by now. If you haven't already done so, go ahead and pause the video, try to do the rest of the problems, and then you can come back and check your answers. So in the next one, it's a number that is less than 1. So we're going to go to the right. 1, 2, 3, 4, 5, 6, 7, and 8 times. So that makes this answer 5.1 times 10 to the negative 8th. Okay, the next one is greater than 1. So we put a decimal right here. So we move that decimal point over to the left 1, 2, 3, 4 times. So that becomes 7.5 times 10 to the 4th. Now the next one, if we go up to the top right, it has a lot of non-zero numbers, and there's already a decimal point in there. Don't let that confuse you. You still want to take that decimal point and move it over so that it's behind the first non-zero number. My apologies for moving things there. This moves over 1, 2 times. Now, we haven't talked about what makes a number significant versus not. We're going to talk about that soon. But essentially, if you've got numbers that are there and they're not 0 at the end or at the beginning, you keep them. So we're going to say that this is 7.59037 times 10 to the 2nd because we only moved it over twice. Next one, we're moving it to the right, the decimal to the right. 1, 2, 3, 4, 5, 6. So that becomes 9.137 times 10 to the negative 6th. Here we've just got all non-zero numbers. So we're going to take a decimal point and put it in right there, and then we move it to the left 2 times. 1, 2. So this becomes 6.84 times 10 to the 2nd. This next one's a very, very small number. So we're going to have to count a lot. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Doesn't matter. We do the same thing. That is still 3.6 times 10 to the negative 14. Now that is quite a tiny number. And finally, we go down here and put our decimal point in. This is a large number, so we're going to the left. 1, 2, 3, 4, 5, 6, 7, 8 times, and this becomes 4.21 times 10 to the 8th. Okay. Next, I'm going to scroll up here, and we're going to work on going from scientific notation to standard notation. So in this case, you might want to pause the video again here and attempt to do this on your own. Or maybe you want to look at a couple examples first. So let's try to do these together. The first one is maybe one of the more challenging ones because it's just 4.2 times 10. Now, I bet you know what that answer is. But let me just point out that if there's not a power there, that means that it's 10 to the 1. That's the same thing as just 42. So what we're doing is if we've got a positive number here, you would move the decimal point over to the right that many times, however many times you have of the power of 10. But like in the next one, we have to the -3. So what we do is we move it to the left 3 times. So sometimes we have to go back and check too. 1, 2, this would be 3. So let me show you what I mean by checking that. If I were to say that this is my number, to go backwards and put it into scientific notation, I would move this over 1, 2, 3 times. The negative can be a little bit more confusing just because you've got to keep in mind that this takes up a spot too. Something to consider. Okay, let's see. The next one is times 10 to the 6th. So we're going to move this decimal over 6 times to the right. Now, if it's easier for you to sort of write that out and move it over, that is totally fine. So that would mean we would have 1, 2, 3 more times. That might be something that you want to write separately, but I'm going to do it this way. 6, 0, 0, 0. Now, if we were starting with our decimal point right here, I've moved that over 1, 2, 3, 4, 5, 6 times, but it's not there. So let's see, there we go. That is our final number. In the next example, we can move this over as well. And if you want to just sort of do what we did above, you can move this decimal point to the right. Let's see what we do. 1, 2, 3, 4, 5, 6, 7. I need one more 0 to get to 8. So 8, 4, 7, 6, 0, 3, 9, 2, 0. Okay. In the next one, we're going to move the decimal point to the left 6 times. So I'm going to do that by starting with a 0 point. And then I need to add in 4 zeros. No, sorry, 5 zeros. And I'll show you how I know that. Okay. The reason why that's the case is that this 4 takes up that last 0, or that last negative. So let's see, we've got 1, 2, 3, 4, 5, 6 right there. That's sort of a way to show yourself that. So hopefully these are getting easier because going into scientific notation is one thing, but you have to be able to think your way out of it too. Okay, so we've now got 10 to the 2nd. So that means that we would move it over 1, 2 times. This would be 237.2. We could take this 3.9 and move it over 1, 2, 3 times. So that would be 0.0039. And again, check yourself to make sure, especially on those negatives. 1, 2, 3 times. That is correct. Okay. Next we have 6.49 times 10 to the 6th. So here we go. 1, 2, 3, 4, 5, 6. Now, if that starts to not make sense to you, add in the zeros. That's totally fine. You can even cover up what problems you have to be able to see it. But especially on those bigger numbers, make sure you check yourself. So let's do that. We've got 1, 2, 3, 4, 5, 6. That's where that decimal point would be, and we're good. Okay. To the -8 next, we know that that 4 is going to take up one of those spots, so that tells me that I need 7 zeros in addition to the one that's before the decimal point. So I'll show you how that works in just a second, but let's try it. 1, 2, 3, 4, 5, 6, 7, and then this would be 8, 7, 9, 2. Let's check ourselves on that. We go 1, 2, 3, 4, 5, 6, 7, and then see how that one takes the 8th spot? That's the reason why we add 7 zeros between this decimal point right here and where this one ends up right there. And last but not least, we've got something in the positive direction. So that becomes 2930. Feel free to check yourself again. We move that decimal point from here, 1, 2, 3 to the right. So I hope that you're getting these. And if not, please feel free to go back and repeat this video. And I hope that helps you learn the concept of scientific notation. Thank you very much.